All right, our second method is variation of parameters. And the amazing news is it's exactly the same method as for second order ODEs. Like literally exactly the same. And so let's solve x prime equals ax plus f, where a is 7 minus 3, 8 minus 3, and f is e to the 2t, 4e to the 2t. Which, by the way, was the same system as for undetermined coefficients. But now I want to show you how to do var of par on this. Now, remember, what is var of par? It's all based on the homogeneous solution. So let's try to find the homogeneous solution. Which just means we need to solve x prime equals ax. So no f term. And that is just the eigenvalue eigenvector method. So here you can check the notes. So we have two eigenvalues. So lambda equals 1 and lambda equals 3. And for the eigenvectors, you can see I was very original here. For the eigenvectors. So for lambda equals 1, we get 1, 2. And for lambda equals 3, we get 3, 4. You know, like 1, 2, 3, 4. See, mathematicians can be funny sometimes. All right, and in this case, what is our homogeneous solution? So you write this as x naught of t. Well, it's C1 e to the first eigenvalue t times first eigenvector plus C2 e to the second eigenvalue t, so e to the 3t times second eigenvector. And we will need to write this in terms of vectors now. You will see why. So x0 of t is now C1, and you just multiply all sides by e to the t. So e to the t, 2e to the t plus C2, 3e to the 3t, 4e to the 3t. So once again, that was our homogeneous solution. And what's the idea behind var of par? Var of par says, guess the same thing, except C1 and C2 are now functions. We're literally varying the parameters. So step 2, var of par. So the idea is xp of t now is, instead of C1 and C2, we do u of t times e to the t, 2e to the t, plus v of t. That's 3e to the 3t, and then 4e to the 3t. And again, once again, it's important to write e to the t, 2e to the t instead of 1, 2. Otherwise, the equations below will be incorrect. But if you plug this into the ODE, which we'll do in the next video, it turns out you get the same var of par equations. I can see next video for the derivation. So it turns out that U and V satisfy the following system. The good news is there's no differentiation involved anymore. So you literally put those two vectors together. So e to the t, 2e to the t, 3e to the 3t, 4e to the 3t. And then, as before, u prime, v prime. And we need a vector on the right-hand side, which here is just an inhomogeneous term. So e to the 2t and 4e to the 2t. So in this case, the form is our homogeneous solution, derivatives, and our inhomogeneous term. And you may wonder, why is there no differentiation? Why is there no zero term? The reason there's no differentiation is we needed to differentiate to get a matrix on the left-hand side. But here, we already have enough info to have a matrix. And for the right-hand side, we needed a zero to get a vector, but here we already have a vector, which is the inhomogeneous term. So it's actually easier than for the scalar var form. And now we want to do Cramer's rule, and all this fun stuff. So remember Cramer's rule, we had to divide by the determinant. So let's do that first. So let's do the denominator. So let's do determinant of e to the t, 2e to the t, 3e to the 3t, 4e to the 3t. All right, that becomes e to the t, 4e to the 3t, minus 3e to the 3t, and then 2e to the t, which simplifies here. So I think it gets 4e to the 4t minus 6e to the 4t, which is minus 2e to the 4t. Always expect some kind of simplification. Otherwise, it would be hard to integrate. All right, and then what is Cramer's rule? So it says that U prime is the ratio of two determinants, one being the determinant of the matrix, which was in fact minus 2e to the 4t, which was calculated. And for the numerator, we take the same matrix, but we replace the first column by the right-hand side. So in this case, it turns out to be e to the 2t, and then 4e to the 2t, and then 3e to the 3t, and then 4e to the 3t. Divided by that, and then you do the math. So e to the 2t, maybe let me do it on a new line. So this becomes, so e to the 2t times 4e to the 3t minus 3 e to the 3t times 4e to the 2t over minus 2 e to the 4t. And this then becomes, I think, 4e to the 5t minus 12e to the 5t over minus 2 e to the 4t. And I think that becomes minus 8 e to the 5t over minus 2e to the 4t, which simplifies to 4e to the t. So that is u prime. And then for v prime, you do the same spiel, but you replace the second column by the inhomogeneous term. So in this case, v prime of t becomes, so we have e to the t, 2e to the t, and inhomogeneous term e to the 2t, 4e to the 2t. And the denominator is the same, so minus 2e to the 4t, which now becomes e to the t, 4e to the 2t, minus e to the 2t, 2e to the t over minus 2e to the 4t. And then that becomes 4e to the 3t minus 2e to the 3t over minus 2e to the 4t. And I think this gives you 2e to the 3t over minus 2e to the 4t. And that's minus e to the minus t. So now we had u prime and v prime. And then to get u and v, we integrate. So u prime of t, I believe, was 4e to the t. And so u of t is integral of 4e to the t dt, which is 4e to the t. Okay. We don't care about constants because we just want one particular solution. And v prime is minus e to the minus t. So v of t is integral of minus e to the minus t dt, which is just e to the minus t. Because if you differentiate e to the minus t, you get minus e to the minus t. Great. And now we have our particular solution. So xp of t, remember, was u of t times e to the t, 2e to the t, plus v of t, like that. So u of t times that, plus v of t times the second inhomogeneous solution, 3e to the 3t, and then 4e to the 3t, which now becomes 4e to the t, e to the t times e to the t, 2e to the t, and then plus e to the minus t, 3e to the 3t, plus 4e to the 3t. And well, here we have exponential terms, so it's actually good to simplify this. So this is the same thing as, I think, 4e to the t. So 4e to the t times e to the t, so 4e to the 2t, and then plus 3e to the minus t times e to the 3t, so 3e to the 2t, and then 8e to the 2t plus 4e to the 2t. And that becomes 7e to the 2t, and then 12e to the 2t. So here we found a particular solution, and then for the general solution, we just need to add this to the homogeneous solution. So x of t is x0 of t plus xp of t. And again, which was c1. Let me write down the new line. So that's c1 e to the t times 1, 2 plus c2 e to the 3t times 3, 4 plus e to the 2t. So I factored out e to the 2t here. We get e to the 2t times 7, 12. And that's all she wrote. So all it is left to show is how to derive the var of par equations, and then I'll just do an extra example.